Let's take a look at the main camera for our project here and take a look at the settings that are within it. So our main camera is a game object, just like any other game object in Unity. It has a transform, which means it has a position, a rotation, and a scale. It's sort of sitting here in 3D space. And if I go and I toggle my global, local axis sort of visualization, I can see that based on my local axis, it's aiming down this blue axis, or it's aiming down the Z axis by default, right? This is the direction my camera is facing in. I could take this thing and rotate it, right? Like this. And it's always going to be looking in that forward Z axis, right? Whatever angle and rotation I have it. All right, let's line this camera back up so I'm getting a nice view of all of these cubes. About here looks good. So I'm gonna select my main camera, go to game object, and say align with view. Excellent. Now if I go to my game window, it looks exactly the same because I've positioned my camera here, right in front of me, right? All right, I've got my transform component. It's got my XYZ position, my rotation, and my scale. Now let's take a look at this camera component, which is everything set up, or all of the settings for actually how this camera visualizes our scene in the game. As I'm working on all these settings here and going through them, I'm actually going to go over to my game view because now I'm actually looking through the camera so I can see what these settings are doing kind of in real time. Now, a couple things about my game window real quick though. The first thing I'm going to do is I want to take a look at this, the free aspect. Free aspect sort of determines the aspect ratio of my game. Free aspect means that I can sort of shrink and scale this thing. But sometimes we might not actually want to look at that, right? Because if you take a look at what this game window looks like right now, it's really tall and not very wide. Most people don't have monitors that are this shape, right? We're developing a video game that people are going to play on a screen. So a lot of the time, what we actually might want to look at this, how we want to look at this might actually be by selecting a different aspect ratio. If we want to look at what 1080p would look like, which is 1920 by 1080 resolution, it would look like this. You can see I get these letter bars on the side, right? And as I shrink, it's going to get smaller. It's going to always be 1080p. I can also look at 16 by 9, 16 by 10, and then some of these other resolutions here. I can look at what a 4K resolution is going to look like, right? I'll leave this at 1920 by 1080, which is probably the most common screen resolution right now in video games. And the other thing I'm going to do is I can also modify this scale value. Sometimes I talk to people and they're like, oh, everything looks super blurry, and it's actually just because the scale is in. So let's pull this back as much as we can. All right, back to our camera component. So the first thing that we have here are clear flags. Clear flags determine what's being rendered behind everything in our scene. Notice how in our scene, we have our cubes, we have our camera, our directional light, we have our floor game object, and then we'll have our cubes, right? If I were to get rid of all of these like this, well, my camera's still rendering something. This. Where's it getting this, right? This is set up as Unity's default skybox, right? It's how it knows to do this horizon in the sky. And if I look at my game view, it's the same thing. It's still got that default skybox. Let's bring all those cubes and all those objects back just so we have something to look at. Those clear flags on the camera determine what's being rendered in the background behind all of the objects that are in my scene. Right now it's set to skybox. I can change this to solid color, in which case I can change which color is being rendered behind all the objects here. Right. I can also change this to depth only, which is essentially just the objects and where they are, essentially. Or I can change this to don't clear, which is kind of a weird one to use. And I haven't seen very many cases of this. You can kind of see what this does if I take my camera and I rotate it while the game's playing. Let's take a look at that. So don't clear essentially means that, yeah, it looks like that. So it essentially means if I'm not drawing anything on those pixels, then just leave the pixels whatever they were the last time the frame updated. So we get this weird smearing effect if I rotate my camera around, right? Yeah, it kind of looks like that. So that's what don't clear looks like, right? I haven't seen very many cases where people actually use that, and I'd love to hear about them if you have ideas on where that's actually used. For the most part, typically we use skybox or we use a solid color. I'll leave it for skybox for now. The background as applied to, I already covered this, mixed, this culling mask. This is sort of what is this camera going to display. I can go and take some of my game objects, and there are these layers that I have in the top right. And these different layers, these are just some of the default ones. And you can hit add layer, you can add custom layers. So I'm gonna just call one called custom layer. And say I take half my cubes and put them on this custom layer that I just created. Well, I can take my camera and I can say, I don't want to show things on my custom layer, right? So see how half the cubes just disappeared. So we can sort of filter out what this camera is viewing and what this camera isn't viewing just by toggling and setting objects on these different layers. The projection. This allows me to toggle between either perspective and orthographic. The best way to view this is actually to go look at our camera back here in the scene view. Notice how there's this white outline of this sort of box here, and I can sort of look off. Let me see if I can disable my skybox here so I get a little bit better view. And we kind of see that this thing is projecting outward, right? This gives me a visual representation of what it is that my camera is looking at. This is called the Vue Frustrum. The frustrum is the name of this shape, right? And when I'm set to perspective, it looks something like this. And I can adjust the location where this thing starts. This is called the near clipping plane, the one that's close to the camera. This other one that's way out here, right? This giant end of my Vue Frustrum, which is as far away as my camera can see, that's called the far clipping plane. I can adjust the near and far clipping plane distances from the camera right here, this setting. All right, so you can kind of see that like the close plane, that near clipping plane, is getting further and further away from the camera. And actually, if we go to my game view and I pull this out far enough, you'll see that eventually it'll stop rendering some of the stuff on screen, right? So notice how I'm only rendering like half of the floor right now. And it's because my near clipping plane, I've sort of pulled it really far away, right? We can see what this looks like here in the editor, right? Or back in my scene view. The near clipping plane of my Vue Frustrum is actually overlapping with my floor, and a bunch of my game objects, a bunch of my cubes are on the wrong side of my Vue Frustrum here. So that's why we can't see a lot of them. So let's pull this back in so we can see everything. Same thing with my far clipping plane. If you're ever talking about rendering distance in a video game, a lot of times you're talking about the far clipping plane. So if I pull this in and I make this really close, we can see that it'll stop rendering things that are far away, right? See how it's not rendering things, right? So this is the far clipping plane. I can visualize this if I go back to my scene view. I can see the Vue Frustrum, and it's only rendering things that are that far away, right? So I want to make this, nice and far so I can see everything in my game. The field of view, which is a very common setting for anyone who plays first-person shooters, sort of allows me to change the angle of this Vue Frustrum. So if I increase it, it gets wider. If I decrease it, it gets smaller, right? So it's more focused, right? This is like tightening in and focusing up what your camera's looking at. Notice how when I tighten this up, though, my game actually ends up looking like it's zoomed in, right? That's just because my field of view is getting smaller and smaller, right? Cool. So this is all settings that have to do with this perspective projection. Perspective is like this. Everything goes out at like an angle based on this field of view. If I change this to orthographic, notice the shape of my Vue Frustrum now, right? It starts as a cube or like as a square of some given size, and it remains that exact same size as far as it goes off out in front of me, right? The end result of this, what it looks like in my game view, is something that looks like this. I have very little perspective of what's going on in my game. Let me swap that back to perspective, right? And then I can swap it back to orthographic. A good way to visualize what this actually looks like is if I take my camera and position it here. Let's just look at, set it at a default position and rotation, right? I'm going to pull my camera back. I'm going to set this to perspective. I'm going to pull it up slightly so it looks like this. All right, now I'm viewing my game like this. My camera is slightly pulled back from my objects and is slightly higher. When I look at it from perspective, I can see the top of my floor here. right? So I get that kind of that angle. When I swap this to orthographic, it looks like this. Everything's flat, right? And we can see it because everything is sort of just flat based on this orthographic view. What would this be used for? Orthographic is typically used for 2D video games, right? If I was doing a completely 2D video game, a side scroller or something along those lines, orthographic is probably where I'd be. If I'm doing a 3D video game, perspective is probably where I'd be, right? Now, what's the difference between perspective and orthographic? Well, if I pull this perspective and I put it really, really, really far down, right? And I go look what this is doing. It's really, really, really focused now. And I can take my camera and I pull it really far back, right? Let's make this really large. Maybe something like that. And I increase my far clipping plane. Notice how back here in my game, it actually looks very similar to orthographic, right? Orthographic, where everything is really flat. Perspective, everything also still looks really flat here, except notice I can still see a little bit of the edge here, right? I get a tiny bit of this perspective, right? So that's sort of the difference between perspective and orthographic cameras. It also covers our clipping planes. Our viewport rect is where this camera is being displayed in our game view. It's got an XY position, which defaults to 0, 0, and width and height, which defaults to 1, which means that this thing's going to be positioned at 0, 0, and it's going to take up the entire width and the entire height of my game. To demonstrate what this looks like, if I set this to 0.5 and 0.5, this camera is going to render what it's viewing at, or render what it's seeing, starting at position 0, 0, which is down here in the bottom left, and it's only going to take up half of the width of the screen and half of the height. If you were making a 4-player multiplayer game, 4-player split screen, you could create 4 main cameras, right? And then you could set 1, so I just duplicated my camera. You could set 1 to be the bottom left. You would set 1 to be the bottom right, right? Which would be 0.5, something like that. You could set 1 to be the top right, which would be 0.5 and 0.5. And then you can see 1 to be the top left, which would be 0 and 0.5. Check this out. Now I have 4 cameras in my game, and I can edit these things independently. I'm going to make this one perspective. I'm going to increase the field of view on it. I'll pull it way back in, right? I'll set that Z back to 0, and then pull it out a little bit. Something like this, right? I'll take main camera 2. I'll put it here. I'll go to game object, align with view. So it looks like that. Now check out my game, right? So I've got 2 cameras that are still pretty much, they're orthographic. And then I've got 2 different views, all of the same exact scene. And if I go hit play, all 4 of these cameras are looking at this scene at various angles. And they're all displaying different things. This is how we could set up 4-player split screen. There's a couple other things here, which are basically how we do rendering. We can render to a texture, which means that we can apply what this camera is viewing onto an object in our scene, as well as a couple of our more advanced graphic settings. In general, this is sort of an overview of the camera settings. So there's a lot of power here and a lot of customization on how we set up what we are viewing of our scene, all within just the default camera component here.